So you might wonder, why do we have precedence rules? Mainly precedence rules are there just to prevent ambiguity. So for example, there's two ways to interpret this statement, 25 star 4 plus 2. One would be to say that the 25 times 4 goes first, followed by the addition. The other way to interpret a statement like this, or an expression like this, would be to say that 4 plus 2 is done first to give you 6, and 6 times 25 will give you 150. So then you have to figure out, well, is an expression like this referring to the result 150, or does it refer to 102? It turns out that almost every programming language that we will run into will use the former. That is, you do the multiplication first, followed by the addition. And that's not just because of the order. So for example, if you have 25 plus 4 times 2, there's two ways to interpret that. One would be to say, just take the order and say, do the 25 plus 4 first. That'll give you 29. Times 2 will give you, I guess, 58. The other way to interpret this would be to do the multiplication first and do the 4 times 2 is 8 times 25 to give you 200. So which one is it, 58 or 200? Turns out it's 200 in almost every programming language that we will use. There might be some exceptions. Okay, so what's behind that? We know that each of these expressions have some, I would say, ambiguity, and precedence rules remove that ambiguity. That's what precedence rules are for. So what is precedence rule? What is it? How does it remove ambiguity? It says things like multiply has higher precedence than addition. That is, you should do the result of the multiply first and then compute the result of additions. So these rules, these precedence rules, remove any ambiguity. There can only be one way to interpret an expression like this. That is, you do the multiply first and then do the addition. And similarly, if you have the opposite or something different like this, you still do the multiplication first and then you do the addition. So this means that you get 4 times 2 is 8. Oops, sorry, this is a plus. I think I gave you the wrong number. So this will do 4 times 2 is 8. 8 plus 25 will give you 33. I think I said 200. Sorry about that. Okay, so in every case, you'll use precedence rules to remove any ambiguity. What if you have the same operator? So here you can have some ambiguity. Say 25 minus 4 minus 3. That if you do this first, this minus operator first, you'll get 25 minus 4 is 21, minus 3 is 18. There's another way to interpret this. That is to say, compute the 4 minus 3 first, which will give you a 1. And then you subtract 1 from 25 to give you 24. So which one is it? 18 or 24? Turns out it's the 18, because the rule in almost every language is that if you have two operators that have the same precedence level, like the minus, it's the same precedence level, you do it in order left to right. Every programming language has that, pretty much has a rule like that. So here there is no ambiguity. You don't do this addition first. If you did this addition first, you would get 4 plus 3 is 7, 25 minus 7 is 18. If you do this subtraction first, 25 minus 4 will give you 21, plus 3 is 24. Which one is it? It's the 24, because these have the same precedence levels, and so therefore you go from left to right. Okay, so I hope that's clear. Precedence rules are used to remove ambiguity. Next, let's take a look at the ever popular post-increment and pre-increment. This always can be confusing at some point. Okay, so let's say we have three variables, n, p, and q. We set n to 1, and then we have p is equal to n plus plus times 5. So you might say what this does is increment n, and you would be completely right in saying that it does increment n from 1 to 2. But here's where you have to be careful. What is the result of n plus plus? It turns out n plus plus returns the old value of n before you do the increment. So if you do n plus plus, n is incremented, but as far as computing p is concerned, you use the old value of n, which is 1. So when you do this operation, when you do the multiply, you do this plus plus first, but that is n is incremented to 2. However, this thing has the value 1. And that is, I know it's going to be a little bit confusing, but this is the same rules as in Java and C++. So if you're used to Java, this should be familiar by now. So this will say p is equal to, it should be equal to 5. Okay? So p, after this statement is executed, should be equal to 5 because n, even though n is incremented, n plus plus has the value 1. At this point, after p is computed, n will be equal to 2. That's correct. And now we have pretty much the same thing as in the previous statement. We're going to compute a value for q, but this time around we're going to use plus plus n. Here the situation is a little different. Plus plus n, what it does is increment n, but also the result of this, or the value of this sub-expression, that is plus plus n, is the new value of n, which is 3. So plus plus n will be 3. 3 times 5 is 15, and so q will be equal to 15. So try this out. Put this into a simple C program, and if you print out p and q, you will get p will be equal to 5, q will be equal to 15. So take a minute, make sure you understand that, because this is very important. This will save you a lot of time. I know if you've used Java, you've probably run into this situation before. Just take a few minutes to try out some examples and convince yourself that that's what you will see. Okay, so those are the answers. If you were to print out p after you compute this value, you should see p is equal to 5. Print out q, you should see q is equal to 15. Make sure that this makes sense, definitely, before you go any further. Okay, expressions in C have the same sort of rules as C++ and Java. They have variables, they have constants, they have operators, and function calls can be part of expressions too. In the end, every expression or sub-expression evaluates to some result value that can be stored somewhere or not stored. So for example, integer division, same rules as in Java, the fractional part is discarded. So if you have 27 divided by 5, you might think that'll be 5 point something, but if it's pure integer division, this will go to a part of the CPU called the integer arithmetic logic unit, and that takes 2 integers as operands and produces one result. In this case, it'll be 5. 29 divided by 5 will also be 5. So will 25 divided by 5. If you have an expression that consists of mixed types, so for example 27.0 divided by 5, there things are a little different. Sub-expressions are promoted just like in C++ and Java. So what will happen is, like in Java, this 5 will be promoted to a double precision number, 5.0. That's how we think about it. And then we do that division, 27 divided by 5.0, that will be done by a certain part of the hardware in the CPU called the floating point arithmetic logic unit. And there it takes 2 floating point numbers as arguments and computes one floating point result. And in this case, it'll be 5 point something. I don't know off the top of my head. But it'll be different. It won't just be 5. This will give you 5 point whatever. Integer only modulo operator works the same as in C++ and Java. You've probably seen this. So the way to think about it is 0 mod 5, and I would say modulo operator. Some people say remainder. 0 mod 5 is 0, 1 mod 5 is 1, 2 mod 5 is 2, 3 mod 5 is 3, 4 mod 5 is 4, 5 mod 5, you have to be careful, is 0. Okay? So once you know that, once you understand that, and then you say, go on, 6 mod 5 is 1, and so on, then you know that 27 mod 5 is 2, 29 mod 5 is 4, and 25 mod 5 is 0. Okay, so make sure you also understand how modulo works. We will be using this operator.